So today I'm going to talk about our smart verifiable computing platform called Brevis. But before I dive into the nitty-gritty technical detail, I just want to kind of first introduce what is the concept of verifiable computing and why is it useful. So like this is the simplest form of computing you can do. Let's say Alice is trying to compute the result of the multiplication equation. Alice spent the computation power to do it. Now, if Alice wants to convince someone else that is not herself that the computation result is such and such, what can Alice do? Well, Alice really can do nothing. Bob here wants to know if the computation result is true. The only way Bob can know it is to do the computation again, which is a recomputation. So Bob spent the same kind of a computation power to do it and then get the same result. That's the only way to do verification in simple computing. The interesting thing here is that the actual cost of computation between Alice and Bob in terms of monetary cost can be significantly different. Alice may be spending $10 to do the computation. Bob may be spending $100 or $1,000 because their unit computation cost might be different. So in this particular case, recomputation is the only way to do verification. But we want to introduce a new form of computation, which is called verifiable compute. In this case, Alice becomes something called a prover. So instead of, in addition to just computing the result of the multiplication equation, Alice here generates additionally a proof called a ZK proof. So the ZK proof is something that is magical. It's very succinct, very kind of a simple thing, but it contains the important elements like what are the input of the computation, what is the kind of computation you're doing, and what is the result. And now, to convince Bob, which now becomes a verifier of the computation, that the result is correct, all Alice needs to do is to submit the proof to Bob. And on Bob's side, all Bob needs to do is to just run a verification function, which is like mathematical magic in zero-knowledge proof, to verify the computation result is correct. Now, the interesting thing here is that the computing power used for Bob is actually significantly smaller than the original computation done on Alice's side. So this way, we can decouple the computation itself from verification, and this is useful because we can now migrate a lot of computing power needed on Bob's side to Alice by asking Alice to generate an additional ZK proof. The nice thing about verifiable computing is that no matter what kind of computation you're doing in the prover side, you can always verify the computation result correctness on the verifier side with constant verification cost. And there is also additional benefit, in terms of privacy, where when you're generating proof on Alice's side, Alice can even hide some input in the computation. And Bob can still verify the computation result is correct. And in this case, Bob is basically verifying, okay, I know there's some number times 121 will equal to the result. And Bob in this case doesn't have to know that what exactly is the number, but he can be convinced mathematically that there exists such a number that can achieve this result. So why are these kind of things important? Why is verifiable computing important, and why we're building a very general framework to enable verifiable computing? Well, because Brevis can actually power a lot of different use cases in blockchain, AI, and Web 2. So let me start with the blockchain side. We all know blockchains are world computers, but they are insanely slow and very expensive computers. They cannot run even faster than a single server. You might think, wait, this is not true because we have a lot of layer 2 scaling and so on and so forth. Well, let me give you a very concrete example. Let's say we want to build in a decentralized exchange, this kind of a very simple feature where you want to give a trading fee discount dynamically to a user who has traded a lot of volume in the last month. If you ever use the Binance, if you ever use the Coinbase, this kind of feature exists in every centralized exchange. But this kind of thing doesn't exist in DEX. Well, why is that? Because computing a user's trading volume, a historical trading volume, directly in smart contract is basically impossible to do. Even this kind of a simple computation, you actually need to spend 40K in transaction fee, 8 hours of computing time just to do it, even on the simplest and cheapest rollups. So the role of Brevis here is to use verifiable computing to again transform and transfer many of the very heavy and complex computation on blockchain to an off-chain environment. And in this off-chain environment, we're generating additionally a ZK proof of the computation result and submit the proof back to the blockchain. Now the blockchain here is acting really as a glue point for many different kind of off-chain computation to verify the proof so that blockchain and smart contract can consume the result of the very complex and heavy computation directly. Now what this enables is really infinite level of scalability with blockchain without any liquidity segmentation or user segmentation that is created by layer 2 rollups. And who are using this on blockchain today? Well, a range of different applications. It's ranging from spot DEX, stable token, RWA asset, liquid rate staking, lending protocol, perp DEX, active liquidity management, and many others are using Brevis to power their new generation application development features. So I just want to give 2 very concrete examples here. First is that we recently launched with Pancake Infinity as one of their, as the only kind of a main partner for their hook-based, swap and spot DEX architecture, where we enable something like what I just mentioned: trading volume-based dynamic fee discount and token holding-based fee discount. So, and this is actually achieving amazing result. We now have $30 million in liquidity, which is like reasonable. But the important thing here is that this feature, even though it is giving discount to the end user, actually are generating higher yield for the liquidity providers. The underlying reason for this is that it incentivizes a lot of market makers to create better market structure for the entire DEX so that uninformed order flow can flow more into PancakeSwap through different aggregators. So this is really not just helping the users, but also helping the protocols and the liquidity providers on top. Another example I want to give is on the RWA and the stable token space. So let's say you launch a stable token, like everyone is launching stable tokens now. And the question is like, what's next? Well, you need to get distribution. You need to put stable token in users' hand. You need to have use cases and usability for the stable token. Well, how do you do that? Well, one important value is to allow your stable token to be integrated and composable in all these DeFi ecosystem projects and across multiple different blockchains. So this is actually turns out to be quite hard because there's no very good way to build an on-chain smart contract that can trustlessly and fairly and securely track users' position across all these different kind of DeFi protocols and measure users' contribution to your stable token protocol and then send reward to them. There's no way to do that today. Well, so what we did with Euro Money, which is like a rising star in the stable token ecosystem, and we're launching with OpenEden very soon, and many other stable token partners as well, is to build this trust-free and provably fair and secure, token distribution, incentive distribution protocol to allow, people to grow their stable token adoption easily. So right now we're distributing about $100 million a year in reward. And with like a lot of unique users and tons of proving requests every day. So finally, I just want to touch on something on the perpetual swap space as well. So we all know what happened on Hyperliquid. Some liquidity provider, some trader really got assassinated on chain because their position is publicly visible to the entire trading community. So what we are working with, with a major perpetual swap DEX partner is to enable this new kind of a perpetual swap experience where you have the Web2 perpetual swap experience, perpetual swap exchange experience in the upfront, but then all of the orders, matchings, and user positions are batched into the Brevis platform to generate the ZK proof of users' actual trading and holding kind of balances. So this allows really dark pools, privacy and security that was not possible before in existing infrastructures such as Hyperliquid. So my prediction here is that in 10 years, 99% of the computation for blockchain applications is going to happen off-chain, and it's going to be powered by ZK proofs and hopefully Brevis. So, and this part is that, you can also use Brevis in AI verifiable inference, but I don't have enough time to kind of go through this in detail, and, we'll just skip it for now. So we talked about what is verifiable computing and why it is super useful and what Brevis can do and already doing with our partners, but what actually is Brevis? What is inside the magic box here? Well, Brevis has really three components. In the center, it's a Pico ZK VM, and then on top, there's a bunch of coprocessors and supported by our prover network. So Pico ZK VM is a generalized ZK VM running on RISC-V instruction set with function level precompiled, allows you to prove really arbitrary computation that is possible. So first of all, Pico is extremely developer friendly. This is how you would write a application in just raw ZK circuit, because like ZK development is quite hard. But this is how you can just write the same Fibonacci computing in Brevis. The reason this is kind of having this developer friendliness benefit is because after all, you're just writing in plain Rust. And Pico is also extremely fast. We're the fastest one on CPU, and recently, just this week, we just announced our GPU accelerated version, which is 20 times faster than our CPU version, and is actually achieving the fastest single GPU proving, performance across all existing ZK VMs. And we are now live on ETH-proof. ETH-proof is this thing that allows you to generate a proof of Ethereum block execution continuously. And right now on the ETH-proof platform, we are about 25% faster than our closest contender in the ZK VM space. But ZK VM is not enough, because there is always going to be this generality and performance trade-off. ZK VM is extremely general, but the generality comes with performance costs. And specialized circuits, writing in specialized DSL in ZK languages have very high performance, but low generality. Where we want Brevis to operate is in the sweet spot between these two kind of trade-offs playing. How do we achieve that? Well, this is the modularity is here to the rescue, where we treat the ZK VM as a glue, but plug in a lot of specialized ZK circuit as coprocessors to improve performance on specific different kind of application use cases. So, for example, on top of Pico, we now have on-chain data access coprocessor, ZKML coprocessors, and the ZK TLS coprocessors, and many others. So on-chain data coprocessor is like a lot of, how a lot of different applications today on Brevis is built on top, like a PancakeSwap, Uniswap use cases. So what it allows you to do is that it allows you to generate extremely fast and efficient proofs of users' historical on-chain data and run arbitrary computation on top, like what is the user's trading volume in the past by aggregating each and every user's trading events. And the result is really kind of amazing, because using this kind of application level ZK coprocessor solution, you can achieve about 80 times faster proving speed comparing to just directly do it on a vanilla ZK VM. And this is like a really unique and special thing about Brevis overall architecture, because we have this modular architecture for ZK VM. And there are so many different, ZK coprocessors and use cases for, Brevis as well. But everything will finally, all of these workload, our partners, use cases will flow into something called a Pico proving network that is coming very soon. So yeah, so this is what we do in Pico. We provide general verifiable computing that is extremely high performance, can scale up blockchain, enable verifiable AI, and new kind of use cases in Web 2 as well. You can follow us here. We just started our community building process and events. So definitely follow us here and learn more. Thank you.